Hi, I'm Paul Curtis. I'm a Principal Solutions Architect at Weaveworks, and I'm going to talk today about moving from virtual environments with Kong into the Kubernetes world and using GitOps to ease that transition. So my bio here, down below, you can see my Twitter handle and my email. I'm not going to go through the whole thing for you. So let's get right to it. So when moving from a virtual machine environment where applications typically run on a single server to an environment in Kubernetes, which is scheduled containers and the routing and API gateways in those containers, we have found that our customers are using techniques to do this very simply. So providing the networking and API gateway functionality, Kong provides that very easily, and it's a seamless transition between what we consider to be traditional application stacks, i.e. based on virtual machines, into the Kubernetes world. But Kubernetes is a lot different, and it's managed a lot different, and we're finding our customers are using GitOps to do this. So I'm going to quickly go through GitOps and give you a quick background on how it works and why you want to take a look at this as a methodology for migration from the virtual machine traditional legacy application environment into the Kubernetes environment. So GitOps is a term that was coined basically by the CEO of Weaveworks a while back, 5-6 years ago now. And it applied itself to our own software as a service. So we run a very large scale software as a service in Kubernetes in the public cloud, and we needed a way to manage it. So we use Git in order to do this. So let's talk about the principles of GitOps and what they are. So the first one is everything is declared. Okay, so Kubernetes is very nice. And Kong's Ingress controllers and operators work just the same. Everything is declarative. I can create declared manifests or Helm charts or customized templates that tell me exactly what I want to be operating in that cluster. So making those declarations means that I can verify, and we'll talk about that in a second, exactly what is running in the cluster. This is different than imperative. So when we talk about a declarative system, what we're saying is that I can have absolute assurance that what I have declared as what I want will actually be running in the cluster, right? And we use different ways to do this. Imperative is like I need to run a command to actually get the action to get taken and the configuration updated or the cluster updated. So in GitOps, we use source code repositories, Git, as the single source of truth. So we put in the desired state that we want, meaning not scripts, but actual declarations. I want this application, these pods, this networking, this storage, and I declare those in manifests or charts so that it's all in Git. Now, I get a whole set of benefits by doing this, right? So those who've done infrastructure as code using source code repositories know this. It's versioned, it's logged, and it's audited. So I can go back and see what changed over time. But GitOps goes the next step. So now we say, now that we have a declared state, we're going to use software agents to automatically apply that or deploy that into our Kubernetes cluster. So instead of saying, okay, I have my configuration in Git and then I run a command, okay, we're going to let software applications do that on our behalf. Now there's some really good benefits to this. Number one, it means that if you forget to run the command, you made the config change, but you didn't run the command, it won't happen. This is an automated process. And so we use the term software agents. And during the demo, you'll see the software agent that we use in the Weave Kubernetes platform is called Flux. Okay, and the last part of the GitOps methodology is that we use software agents not only to deploy things, but to constantly reconcile what you've declared versus what is actually running in the cluster. And it can alert you when there's a drift or a divergence. This is what makes it very different than infrastructure as code, because it is constantly monitoring what you declared and what's running in the cluster to ensure that they are kept the same and they are kept correct. So when you look at the overall pattern, you have on the left side here in red, you have the normal CI process. So how you develop your applications, how you build them, how you save them, how you compile them, whatever you're doing. And in our world in Kubernetes, then I make containers out of them. That's one side of it. Once the containers are done, I now can say to Git, okay, here's how I want it deployed. And the right-hand side takes over. So it deploys it, and then it watches. So it's constantly reconciling what you've declared versus what is actually running in the cluster. And anytime that there's a divergence, obviously it's going to tell you. Now, for those who are used to source code, this brings a lot of very easily identifiable benefits. And the first one is that like a source code release, a deployment release can use the same tools. So if you do pull requests or you do merges into branches, there's a lot of ways that you release application software. Take that same mindset and apply it to deployment, and you begin to see that, wow, that process looks very much the same. Now, when I actually do the merge or the git push, my software agents are taking care of actually deploying it. So your interaction is only with the Git repo. You actually don't ever have to do a command line, nor do you ever have to have the credentials to operate the cluster on your machine, because you're only interacting with Git. Now, that means in source code releasing and versioning, I now can roll backwards very easily. Right? So because I have every version of every change, if I've deployed something and I need to roll back to an earlier version, I can do one of two things. I can move the commit ID on the head branch of that particular Git repo directory or branch back one commit ID, and the software agent will very happily redo that for you. Or I can commit a new version with the proper versions in it. Either way, I have all of the changes recorded. I know who did them, when, and what they changed, because the source code revision tells me very specifically how it was modified over time. The power here is that everything becomes observable to the developer. So if there's a problem, the developer can just go to the Git repo and look at what was deployed or is currently deployed and say, hey, wait a minute, that's not exactly right. That's the wrong version. That's the wrong container. That's the wrong tag. That's the wrong parameter, argument, environment, variable, whatever. And it can be easily fixed by making the change, committing it, and pushing it to that repo. The software agent will pick it up, see the change, and then apply those to the cluster. Now, in the last part of this, understand that Kong as a toolkit and an API gateway in the Kubernetes world is an ingress controller, okay, and ingresses. The benefit here is it's all declarative. So that means everything I just described to you can be applied to any of the Kong tool sets, not only the ingresses, but all of the rules and routes that go with that can be declared in the same way. That gives you a complete insight to exactly what's configured in Kubernetes, and you can monitor it. In addition, if there's a problem, you're going to get alerted to it not working properly. This gives you a complete picture of the whole cluster by looking at a single Git repository or a single source code repository to find out exactly what's running in the cluster. So what does Weaveworks do? Just for a quick one, we built all these tools. So when you look at tools that you're going to see demonstrated like Flagger and Flux, Scope, EKS Control, these are products and things that our engineers have created and have contributed to the open source community. So this tool set now we put together and package up and we give away and provide support for all of these tools packaged up. But understand that we use these tools day in and day out to run Weave Cloud, which is thousands of clusters being monitored all over the world. And there's, I don't know, millions upon millions of data points that are captured. This system has to be up 24/7 because our customers rely on it. So I'm going to stop now and we're going to head over and do a demo. Okay, now we will use a quick walkthrough demonstration to show how you can deploy Kong's Ingress controllers in Kubernetes using GitOps. We'll start off with a very plain Kubernetes cluster. As you can see, there's very little here. What has been installed is the Weave Kubernetes Platform software agent Flux. That instance of Flux is attached to this Git repo. Now, as we work through the demo, we will not be interacting with the cluster directly, but rather with this Git repository. So the first thing that we're going to have to do is install the Ingress controller. We're going to use the standard Kong Kubernetes manifest files in order to do this. So what does that look like? This is the standard file, so this will deploy all of what is required to build the Ingress controller for our cluster. By default, it will install it as a load balancer as well, so we will have external access to this cluster. Very quickly, you can see that the Ingress controller is running, and we will want to check the services to see when the IP address and the host name are assigned to that load balancer. Once the load balancer has been deployed, we can use this host name to access the services that we're going to deploy into our cluster. So we'll put this into a tab so that we can pull it up later. Now let's go on and deploy an application. The first one we're going to deploy is Weave Scope. And I do that because Weave Scope allows you to visualize the cluster in a running sense very, very easily and very simply. Again, because everything is being done through Git, we will be able to see the deployment as it comes out. Now you'll see here's the manifest for Weave Scope, and here is the Kong Ingress for it. The path we've assigned to it is /scope. So let's take a look at what that looks like. You can see here's our cluster. Scope is a visualization tool. This allows us to take a look at what's running. So you can see right here, here is the Kong Ingress. You can see it's connected to the internet as well as to the Weave Scope app itself. Now this is a very simple demonstration. So let's go the next step and actually deploy an application. When we look at all the pods, we can see the interconnections. So let's see what happens when we actually add an application. So we've added a very simple application here called pod info. Pod info will show us a very simple echo service that allows us to control what we can see and check pods, check routes, things of that nature. We have deployed it to the root path. So it should be very simple to get to, right? So the application has been deployed. Here's the pod itself right here. When we look at the services that have been deployed, you can see that they're interconnected. So here is the pod service right there. And now we should be able to go in and very simply get to the pod info application. This gives you the ability to do many things with Kong. First one is that everything that we have done has been audited. So I can show you very simply the last set of changes that were made. And you can actually see that what we did was we added an application, we added a service, and we added an ingress. Everything has been logged in Git, and everything is viewable by everyone. If I make a change to this Git repo and any of these manifests in here, they will be reflected in the cluster almost immediately. This also means that any services that are running in the cluster can be connected via Kong to any legacy services that already exist. Thank you for watching this quick demo of deploying Kong in Kubernetes using GitOps.